we've had a couple presentations before. I did one, I think, and I think you did one, maybe, Carol. There's a couple ways to approach it. If we can get materials up there easily on a space elevator or something, then we can manufacture stuff up there that we can't manufacture down here on Earth and send it back. But I think maybe Jason mentioned it in passing. We can also, I was talking one time, maybe a year or two ago, about mining asteroids out in space.
Yes.
And
In other words, you
that
wouldn't have
would
to
move
lift the
that would
material.
move our dirty extractive industries off of Earth out into space and help preserve our environment, and also give us access to a great deal more of minerals and other natural resources that that we may be able to process out there, send the finished products back to Earth or to a space station or wherever they would be needed.
Or use that material to build space stations and satellites and everything.
Yeah, whatever's
In other words, you don't have to lift it from Earth in order to build with it in space.
So that would be a next step beyond what we're talking about here today.
Yeah.
I think that might be several steps.
Yeah,
The energy to get to the asteroids, then mine it and then get it back.
Yeah.
Yikes.
I think it will happen this century.
Now, there's some interesting stuff going on with solar sails. You know, when it comes to getting to the asteroid.
Okay, Chris.
I wonder if there would be some benefits and some economic advantage to setting up manufacturing on the moon. We get significant, it approaches zero gravity.
1/6.
It might get close enough to the to zero gravity or low gravity in order to be able to get many of the benefits of zero gravity at a lower cost, where you could build manufacturing facilities on the moon and use the materials of the moon.
Yeah, I think the gravity would be too much for the types of materials we're talking about manufacturing in this presentation, but the fact that it's near vacuum there and other factors like that could encourage manufacturing on the moon.
And also get on and off it a lot easier once you're there.
Yeah, it's easier to get on and off the moon than it is Earth.
And Lynn.
Thank you. I've got my environmentalist hat on.
Okay.
We used to think that the ocean would take all the garbage we could put in it and ask for more. We used to think that minerals that came out of the ocean or out from under the ocean were inexhaustible. Human beings are theoretically capable of learning from experience. I don't see that exemplified in the talk about the way we could and undoubtedly will use outer space. Thank you.
Well, one thing in outer space that is very definitely a limited environment, and that is like low Earth orbit. If you get enough shit in low Earth orbit, you can't launch through it. You can't, all of a sudden it's not space anymore. It's space with things constantly zooming through it.
Same with geosynchronous orbit. That thing's getting pretty packed.
Yeah.
Yeah, especially with Elon Musk's hundreds of satellites and so forth.
Yes. So I mean, definitely throwing things away in space when it comes to certain areas of space is already a problem. However, you know, we're doing all of this bit with artificial intelligence. And real artificial intelligence requires unbelievable amounts of computing power. And it requires enough computing power that it is actually affecting the environment adversely on Earth. You know, simply cooling all of these, the heat put out by all of these computers is becoming significant. And it would be perfectly possible to build a computer on the vacuum of the moon or in orbit and radiate all that heat away without messing up the environment on Earth. Jason.
Again, I'll take my hand down and finish my comment. I think there's a false equivalency here, or this is not a good analogy. I like to make comparative historical examples, but we face far more danger presently by polluting our own microcosm. Where possible, we should endeavor to export all of the as much of the damage to our Earth's environment as possible to the extrasolar arena, endeavoring where possible to preserve ecosystem, the moon and Mars, in our drive to terraform and colonize such celestial bodies. But the vastness of space and the universe and just our own galaxy is inexhaustible. We would be able, with the resources out there, to become not only a type 1, a type 2, a type 3, hell, even a type 6 civilization with such resources given time. It's just a race for technological process and primacy to be able to harness those resources. I think that in the long term, we need to think about our human survival as a species. We have far more pressing problems here on Earth today than even global warming, number one of which being our continued existence here with the rise of international conflict and the capability of our weapons platforms, or even just asteroids threatening our home, or microorganisms that threaten to eradicate our species entirely, as it is contained to this one small blip.
Okay, could we try to keep it a little short and on point?
Yeah, it has been.
But
it has been said many times
that it would be premature. I think that it would be foolhardy to halt what little progress we're making at the snail's pace that we are, due to irrational environmental fears at this point in time. That's what I wanted to say. Thank you.
It has been said a number of times that the Earth is too small a basket for the human race to keep all of its eggs in. The survival of humans as a species would be improved if we didn't all live on the same planet. So, yeah, I agree there. Tom, are you next? Tom.
Tom, yeah.
It's time to start consider seriously occupying the Lagrange points.
Well, that's just what I was going to talk about.
Okay, well, you talk about it.
No, you have the floor.
Oh, well, that was all I was going to say. This is a Arthur C. Clarke science fiction suggested that there be stations at L3 and L5, but there are other such points in the solar system, not depending on the Earth Moon, but Earth Sun relationship points as well. We have to find somewhere else, and somewhere else that's not at the bottom of a gravity well, even a small one, can be an advantage. Now, granted, there are times when gravity is a useful thing, but not always.
Yeah, the most stable Lagrange, the Earth Moon Lagrange points aren't real stable. The most stable ones are L4 and L5 with the Earth Sun system. And at least one of them has a couple asteroids sitting in it, which may or may not have some important minerals in them. We'd have to go check those out. But so we have starting points to do this manufacturing in an easy, as Tom said, low gravity well, where it's easy to get things in and out of, but is a stable area, gravitational area. So things wouldn't escape orbit and tend to get lost. So there are definitely certain ways to do this in certain places that would be more advantageous to do it in.
How big are these Lagrange points, and how far would the trip be to get there?
Well, L4 and L5 are about what, 1/6 of the way around in Earth's orbit, in front and in back of the Earth. So it's pretty far.
They're just.
How big are the size in terms of field?
Well, it's not like it has a hard border or anything, but you think of it as a gravity well. It's a small gravity well that I don't know, hundreds of kilometers wide, probably.
Well, what the Lagrange points are stable points, such that if you have an object in a Lagrange point,
it'll stay there. It'll
and you perturb it away, its tendency is to come back,
right,
rather than to be, to keep on perturbing.
As I said, L4 and L5 are the most stable ones. The slightly deeper gravity wells. The ones with the moon are not very stable. But we should move on.
Okay. All right. Back to this.
Now, being the first time I recorded, I have an option here to pause or stop recording. Does pausing work? Does anybody know about that?
Pausing should stop the recording, but keep it available to be restarted, to be continued.
What would be better is if it stops the recording and starts it again, but keeps it in the same file without splitting up into different MPEG-4s. So I think I'm going to try pausing.
Yeah, I think that's what you want.
Shall I do it now, Carole?
Show you what?
Pause the record.
Yes.
Okay, you're going to show video?
Well, no, you should pause it when I get to the video, which I
Okay.
am going to very shortly.
Oh, no problems. Go ahead.
But I thought I would mention this as the obligatory science fiction reference. And I have really only run into one science fiction book that talks about the sort of manufacturing that we've been talking about so far. And this took place in Andy Weir's second novel. After The Martian, he wrote Artemis, and it's about the existence of a moon colony. And it's about the economics, the tourism, the everything about a moon colony. And one of the plot devices he has there as a mystery sort of thing is a sort of super Z-blan. Remember, Z-blan was the fiber optic cable that doesn't require as many repeaters. It has a much longer length. You can send a cable without it becoming attenuated. And in Artemis, he talks about a material that is called ZAFO, for zero attenuation fiber optic. And that means no degradation of the signal. You need no repeaters. You can put fiber optic cable under the Atlantic from Europe to America and, no repeaters. And just so happens that this particular thing can only be created cheaply. By the way, can you see this? Or
Yeah.
Yes, yes.
Okay, I am screen sharing. This can only be created cheaply at 1/6 G, which happens to be the surface gravity of the moon colony. So, I at least found one reference to the sort of manufacturing things that we've been talking about in science fiction. Let's see. Okay, I have one more video, and this is much more about the Varda thing and their drugs from space, and also about what the Space Forge Company is doing. And let's see, I will stop sharing and Tom can start this up.
Okay.
Okay.
I don't see any hands up.
Oh,
We've already covered a lot of this material, I think.
yeah, but this gave, good detail. Like it, it really showed you the infusion process versus getting a shot, that type of thing. I thought it was important. Stan.
Well, I want to congratulate you for finding that video. I'm going to try to re-look at that, and I need to break it down. And when I watch videos like that, I stop and I play it back, stop and play it back. Being familiar with, I think gallium arsenide was used by Seymour Cray. Correct me if I'm wrong, Tom Trites, for the Cray 3. He was basically involved with that. And there's no doubt that
Is that the one that looked like a burgundy piece of furniture?
excuse me?
That Cray?
Cray 1, the Cray 3 would be, I don't know. I don't,
The furniture thing was the Cray one.
Cray 1 was like a cylinder a couple feet in diameter.
yeah,
And it had a couch around it.
yeah.
Well, no, it
That wasn't
had,
really part of it.
it was a power supply surrounding it and two air conditioning units, but they were covered so that it looked like a couch.
Okay.
You could sit on it, but it was not recommended.
I think the Cray 1 was featured in a movie with what was it, Network or something like that. But anyway, the Cray 3, I think Seymour Cray was preaching gallium arsenide as the substrate for that Cray 3 for improved performance.
Mhm.
And
That is true.
Everybody was.
yes, but it's not very affordable. I mean, it
No.
fails the affordability factor. But that's when you're looking for efficiency and that kind of thing with the quality and the efficiencies of that, it certainly is very very attractive for specific purposes.
Jason?
This will probably be my last comment before I lose contact due to my power loss. But my final is this. I really want
What?
to spark the space-based industrial revolution. All of our R&D in zero G has been limited to the things that we have attempted to manufacture here on Earth, found that we couldn't do it in 1G gravity, and then sent proofs of concept out into the space station, etc., to see if it's plausible to do it up there.
Mhm.
We are only touching the periphery of what is possible. In order to really
Mhm.
innovate, we need to build R&D facilities in outer space and staff them with industrial and material engineers. And like,
And as a matter
like Tesla's and Benjamin Franklin's, they need to tinker and find out what they never knew was possible, or things that conclusions or outside of adaptive AI algorithms, things that we could never have discovered accidentally or on purpose here on Earth to even think to try to manufacture them in outer space. So we need to set up.
As a matter of fact, Jason, the two videos that I have for future describe just such facilities.
Wonderful.
So
Yeah.
try to hang on and you'll get to see them.
Okay, H-Town.
I doubt that I'll be able to stay online that long, but thank you for your presentation, Carole. You've done a wonderful job so far.
Well, before you leave, Jason, can you give us the topic for your talk next week again?
Be presenting next week at same bat time, same bat place. We will be looking at the future of post-secondary education and the crisis we currently face and how the future will rectify that financial situation, and also academically, and how we will be able to more broadly offer post-secondary education options to the masses more economically, more efficiently, and more effectively for our economy in terms of the quality of content and also the way we deliver it to public.
Okay, thanks.
I encourage you to take a look at Western Governors University and the increasing online options that are available attending college remotely online. like ASU and others. All right, thank
I
you.
hope you will give us this material when we, in your presentation.
Yes, of course.
Okay. We won't have to go find it for ourselves.
H-Tom?
No.
I think we are going to find a vast change in how we approach the problems of zero gravity at all. Once we have people who are born and have children in zero gravity, people who are not born with the muscle structures, muscle memories, the mental maps of down that you grow up with being born and living in a 1G field.
Um,
And McCaffrey's, what did I think? Has one of the early books in the Vorsagonal series has people who are, I can't remember. It's been too long. I'll look
I
for
thought
it.
she wrote mostly about dragons. Whatever.
That's
that was her earlier stuff.
much earlier stuff. Anyway, next.
Okay, are we ready for the next video?
Well, it depends. Are we all done with questions?
Yeah, I see no hands.
H-Tom, I think it's going to take a lot of experimentation with mammals before people would be willing to have a pregnancy in 0G. Because, I mean, God only knows. I can see it's not just a question of doing it, is what I'm saying.
No, it's
There would be major things to worry about in terms of fetal development.
yeah.
Yeah,
Pretty bad for you. I mean, we already know that your brain swells. There's all kinds of terrible things that happen to you.
yeah, but humans often find a way to do it anyway.
Yeah.
Oh, sure.
Well, as a for instance, for all you sci-fi fans, if you remember Larry Niven's stuff about he has a civilization in the asteroids, people who are always in 0G, except when they want to have children, the women go to an asteroid that has a fairly significant gravitational pull for the duration of the pregnancy. So this is something that's been thought about.
Or you can live inside an asteroid and spin it up to create an artificial gravity.
Yeah. But I mean, it's just the kind of thing where, he has seen the possibility of serious problems, and it's been thought about. Carrie?
I was just going to say real quick that there's a series of books they turned into a series called The Expanse.
Yeah.
Kind of is I don't know. I think, outside of the alien stuff, is a pretty good exploration of an intermediate step of what we could probably conceivably do in the solar system, absent radical, changes in technology.
Mm-hmm.
Yeah. Stan.
Didn't they make a big TV series out of that?
Yeah, that's what I was talking about. There's a series of books that he wrote first. I don't know what they're called. I don't think they're called The Expanse, though. I think that was the TV show. But I mean, if you look on Amazon, you can find them.
Leviathan Wakes.
There's a ton of it's a whole series of books.
Was one of the books.
Okay.
But anyway, that's the only one I remember. Stan.
There was the movie Wall-E by Pixar, and the idea was that they abandoned Earth and they had these huge spaceships for humanity to hang out in until Earth was recovering from its climate problems. I guess my point is that if you have a human race that's basically developing in on not zero gravity, with the idea of having them return to gravity, that may be a problem. They may have to be people who have decided to spend their entire life in zero G and not have the opportunity to come back to zero gravity, maybe or come back to gravity, or maybe they can. I don't know. That would be an issue that would have to be tested as well.
Well, I think we have the experience with our people who went to space that people who spend months and months in zero gravity have to be seriously doing exercise that mimics weight-bearing exercise, or they literally have to be carried off of the, the first few times this happened, these people couldn't walk when they came back to Earth. And they developed, the sort of exercising that could be done that exercises the long bones and keeps you in shape for going home.
You also have to relearn how to move your body properly because you just learned a new way to do it.
Yeah.
Yeah, there's a recovery process when you come back, and it's quite extensive from what I understand.
Okay, the next video is only about 4 minutes long. You want to show that?
Yes. Now let me see.
Orbital Reef.
Do we just have that for future?
There's two more. There's Orbital Reef and then Axiom.
Yes, and both of those are under the category future, and they are development things that are in development for having the kind of great big live in and do experiments in space station that Jason was talking about.
Okay, let's get to the future then. Is this it here? Axiom Space Station?
Yes.
Okay, here we go.
On Axiom, and it's basically a comparison of Axiom and Orbital Reef. So yeah, a lot of this is repetition.
So I guess I'll continue for the next 2 minutes.
Okay, I don't.
Just a bit about the production values here. The music's way too loud.
Oh, okay.
It looks like we lost 1 or 2 more people.
Okay.
So I see no questions. You have any kind of summary, Carole?
Well, when I started researching this, I had no idea that we were actually doing manufacturing in space now. I mean, I knew about the various experiments that had been done on the space station, and I knew about the types of things that they were looking at, but I had no idea of what Varda was doing, and the fact that they had actually made the drug and brought it back to Earth and used it. And so we were further along than I thought. How's that?
Carole, did did you say that the ZAFO, the zero attenuation fiber optics, was that just a sci-fi reference from that?
Yes.
Yeah.
Okay, so that's not data that, okay, so that's, okay, because the idea that you can actually improve the quality of the Z bland, which is already an existing product,
Yes.
which can hit from the States to England without any kind of boosting. And that had to be done in space.
Yes.
But the idea you can actually go to the moon with 1/6 of the Earth gravity and get one that's kind of sounds like zero resistance electric so superconductivity in
Yes.
fiber optics.
Yep. That's what it is. That's what it is.
Yeah. I was just saying that that's the only science fiction reference I have seen to manufacturing in 0G or very low G to improve fiber optics.
So we don't know whether the author, and I know that you and Jason know this author well, but does he have the scientific credentials to sort of make predictions like this, or is he just writing off of a creative?
No. Andy Weir, the fellow who wrote The Martian, is a really, really, really serious space buff. I mean, he knows all about what's going on in space. And, you know, he wrote The Martian as a totally scientifically accurate book. And he again tried to write Artemis, which is about a moon colony, talking about totally accurate issues of the economics of a moon colony and the requirements, you know, for building materials and the atmosphere that you're keeping. And he is extremely well versed in science and in space-related science.
One of the things that occurs to me is that with these space stations that we're looking at, the Orbital Reef and the Axiom sort of deal, the idea of the notion of supply chain problems comes to mind. You get these brilliant guys and gals up there, and one of them goes, you know what we need? We need to make this, but we're going to have X, Y, and Z. Get something on the phone and get it up here by tomorrow. Not going to happen. You know, I mean, I don't know how you can possibly get these labs supplied with the correct materials for them to have a long sequence of runs that don't need something. I mean, that was the whole thing behind the made in space 3D printer, was that if you didn't have a tool or you broke it or something went wrong with it, you could make it again in space, you know.
Yep.
Yes.
Which turned out to be an incredible concept, but you can't invent materials, you know. And when Jason said something about H3, I did some research on that. I don't think I'd ever even heard of H3 before, but apparently it's very useful for fusion reactors. Helium-3, I should say, not H3, but helium-3. So yeah, getting these space age materials requires some ingredients that you don't.
I thought fusion reactors went for deuterium rather
than for the actual. That's for the actual fuel, but I'm assuming that the helium-3 is something more to do with the actual making of the confinement.
Yeah, okay. I
I think
I'll
it's
have to look that one up.
to control reaction, help with cooling and so forth. I have three things before we sign off here. One is just another science fiction reference. If you're talking about colonize other planets, Kim Stanley Robinson's series, Red Mars, Blue Mars, Green
Green
Mars.
Mars.
There's a lot of science in that. There's a lot of politics too, but those are very interesting. Also coming up at the university this Wednesday evening as a meso family lecture put on by the physics department, I believe they're going to be talking about graphene and certain forms of graphene are best manufactured up in space. I don't know if they're going to talk about the manufacture of it itself very much, but more the uses of it, twisting it and all the different properties of graphene. That can be very useful.
Now, wait a minute. When and where is this going to be?
It's at the McNamara Alumni Center on the university, not far from the stadium, at 7 p.m., Wednesday, the 18th. But you should get online because they do want reservations. It's free, but they want to control the size of the crowd.
You know what the capacity there is, Tom?
It's in Memorial Hall, which I think is the largest hall. It's probably, I don't know, if not 800. It's pretty large. I don't know what the capacity is. So it's not like a classroom size or something.
Right, but so I should just look up graphene lecture or
Yeah, that will
to
probably
find it on
U of M. Yeah.
Okay, U of M graphene lecture.
Yeah. And the last thing I wanted to mention is 2 weeks from now, I'm going to be talking about cleodynamics. And that is basically the study of history amassing vast amounts of data that we know about different civilizations and governmental bodies, nations, and well, nation states are fairly recent, but over the last couple thousand years, and extracting patterns from that mathematically and creating mathematical models that can produce predictable results and verifiable results and can be projected into the future. So that's going to be an interesting topic, and I think it's not only interesting about the future, but it's pretty, it relates to current events too.
You mean interesting or terrifying?
Yes.
Puts me in mind of Asimov's
Yeah, a little bit like,
history.
yeah, psychohistory.
There we go. Sorry.
So that's all I have.